three-dimensional geometry. So we are going to have the two-dimensional geometry you have learned, whereas the x-axis, y-axis and z-axis, three axes are there. We are going to have the three-dimensional geometry. We call it as a three-dimensional geometry. So now here, direction cosines of a and direction ratios of a line. Okay. Directional angles we call actually. What is meant by directional angles means the angles made by the line with the positive direction of the x-axis, y-axis and z-axis is called direction of angles. So usually the alpha, beta, gamma is directional angles, will denote it. Then the cos alpha, cos beta, cos gamma are called directional cosines of a line L. So we are going to learn in this chapter. Can you hear me?
Yes, sir.
We are going to learn line and plane. How do we represent the equation of a line? How do we represent the equation of a plane? We'll see in this chapter. Okay. So directional angles means if a line is making an angle with the x-axis, usually x-axis is denoted by the line towards our side. When you are in the a room, suppose if you are staying in room, the left side corner, you see that is origin. You consider it as an origin, and the line which is towards you, you consider it as a x-axis, and the line which is opposite to you, y-axis, the line which is upwards is a z-axis. Can you imagine that here? The room. Okay. So like that, when you take into consider, if a line is making an angle of alpha, beta, gamma with these coordinate axes, then the cos alpha, cos beta, cos gamma is, they are called as directional cosines of that particular line. So by normally we denote that cos alpha, whatever it is, by the L, and cos beta by the M, cos gamma by the N. So we call them as a directional cosines. We call them as a directional cosines. Okay. So usually we denote it by the alpha, beta, gamma are the lines, angle made by the line with the x-axis, y-axis, z-axis, means that cos alpha, cos beta, cos gamma are the directional cosines. Okay. Thus the directional cosines of the line are, in case if it is in anti-clockwise direction, if you are taking pi minus alpha, means clockwise direction, if it is making an angle, okay, anti-clockwise direction, pi minus should be taken into consider. So if a line is making, this line is making an angle, L1 and L2 lines, two lines if you are taking into consider, if the two lines are parallel, then they will make an angle with the axis with the equal angles. Then the direction cosines of that line and direction cosines of the second line equal. So direction cosines of it. So relationship between the direction cosines. So normally we are going to have the relationship between the direction cosines of a line. That is L, M, N are the direction cosines, means L square plus M square plus N square is equals to 1. We are going to get it. So that how do we get? Let us see here. Let us take a point P on the line L1. That point P is XYZ. So from that we take that OP is equals to R. So that is nothing but the distance between the point origin and that point is equals to R. Let us take. So from this x square plus y square plus z square is equals to R square we will get. If you drop the perpendiculars from that point to the three axes, you imagine that the figure, whenever you are taking into consider, three coordinates should be taken into consider here. Right-handed system. The line which is towards, means in the room, you imagine always you imagine in the room, wherever you are sitting in the room. If you are sitting in a room, you imagine that the corner point to your left side is the origin always, so that the imagination is really good. So you take the one point P is taken in the space Here like this, the space is taken. From this point, perpendicular line to the x-axis is nothing but x-axis. We are taking perpendicular line. That is nothing but we are dropping the perpendicular line from the point to the three different axes. When you drop the perpendicular lines to that, so here when you take that OA, OB, OC, these are all perpendicular to PA, PB, PC. So OA is equals to X, OB is equals to Y, OC is equals to Z. Let alpha, beta, gamma are the angles made by this line with the X coordinate axis. Then the cos alpha, cos beta, cos gamma are direction cosines. So cos alpha, what do you get from this? In the right angle, actually OAP is a right angle triangle. OA, because in this, can anyone tell me what is hypotenuse?
R.
R is a hypotenuse. Very good. So cos alpha is nothing but, in this situation, x by r we are going to get. That is nothing but L is nothing but x by r. In the same way, cos beta is nothing but, so x is equals to LR. In the same way, OBP right angle triangle, when you take cos beta is equals to M, that is y by r, y equal to mr. In the same way, z equal to nr we are going to get. So three equations, and we are having that x square plus y square plus z square is equals to r square. In that, whenever you substitute, we are going to get it L square plus m square plus n square is equals to 1. So that is nothing but sum of the squares of the direction cosines of the given line is equals to 1. So these are called the direction cosines of any line. Okay. So x is equals to LR, y is equals to MR, and z is equals to NR. Direction ratios is nothing but any three numbers which are proportional to the direction cosines of a line are called direction ratios. So direction cosines element means direction ratios, or you can take a of a line is usually represented by ABC. They should be proportional. So L can be written as A into lambda, M can be written as B into lambda, N can be written as C into lambda, where lambda is not equals to 0. Not only that one, any number. The numbers which are proportional to the direction cosines are called direction ratios. Okay, the relationship between the direction cosines and direction ratios means whenever you take the ratio of the direction cosines of a line and direction cosines ratios of a line is a constant always, because they are proportional. As they are proportional, there will be a constant. So from this we are going to get it L square plus m square plus n square is equals to k square into a square plus b square plus 1. But we know that sum of the squares of the direction cosines is 1, L square plus m square is there. 1 is substituted means k value constant we can find out as 1 by plus or minus 1 by under root of a square plus b square plus c square. That means if a direction ratios are given to you, direction cosines you can find out in easiest way. How do we find out? If 2 comma 3 comma 4 are direction ratios, 2 by under root of 2 square plus b 3 square plus 4 square is a one direction cosine. Like that, another one is b by under root of b square plus a square plus b square, and c by under root of a square plus b square plus c square. We are going to get direction cosines. If direction ratios are given, direction cosines we can find out in this way. A direction cosines of a line passing through the two given points. If you want to find out the two given points are given to you, we have already learned slope finding in 11th class. When the 2 points are given to you, how do you find out the slope?
y2 minus y1 by x2 minus x1.
Yes, y2 minus y1 by x2 minus x1. So here, if you know the 2 points on a line, and if you want to find out the direction cosines of a line passing through that point particularly, so that cos alpha, cos beta, cos gamma, whenever you need to find out, okay, so that how do we get here? In the right angle triangle BAC, cos beta is equals to AC by AB. So AC is equals to Y2 minus Y1. Okay. And BC is equals to, BC by AB is equals to the distance between the points, 2 points. Under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So cos beta value, we are going to get y2 minus y1 by under root of. So in the same way, if you want to cos alpha is nothing but x2 minus x1 by the distance between the 2 points. Cos gamma is nothing but z2 minus z1 by distance between the 2 points. That means direction cosines of a line passing through that point you need to find out. Means actually direction ratios you can find out just by subtracting the two numbers x2 and x1. If you find out direction ratios, direction cosines easily you can find out. Direction ratios, how do you find? Simply x2 minus x1 is y2 minus y1, z2 minus z1 are direction ratios. If you know the direction ratios, direction cosines, ABC direction ratios means direction cosines what? ABC direction ratios means direction cosines is yes, tell me. Suppose here if you are taking direction ratios and direction cosines, you need to find out me. Very simple task is that if you are taking A comma B comma C, A comma B comma C are the direction ratios means plus or minus A by under root of A square plus B square plus C square plus or minus B by under root of A square plus B square plus C square plus or minus C by under root of A square plus B square plus C square. These are the direction cosines. This is direction cosines. And these are the direction ratios. Suppose any line, if it is given to you, the 2 points on the line given to you as x1, y1, z1 and x2, y2, z2. The direction ratios of a line passing through these 2 points can be found out just by subtracting x2 minus x1. This x2 minus x1 is A, and y2 minus y1 is B, and z2 minus z1 is C. So this is A, this is B, this is C. A, B, C if you are finding direction cosines. So don't try to remember that if the 2 points are given to you, passing through the 2 points, if you need to find out direction cosines means if you try to remember x2 minus x1 by under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, it looks like a very complicated one, isn't it? Did you understand?
Yes, sir.
Any doubt in the direction cosines and direction ratios? Simple task is that if direction ratios is nothing but the numbers which are proportional to the direction cosines. So A, B, C usually we denote by the direction ratios. L, M, N we denote by the direction cosines. L square plus M square plus N square is equals to 1. A square plus B square plus C square is not equals to 1. A, B, C are there, but they are proportional. That is nothing but that when you are dividing the A ratio of A and L, ratio of B and M, ratio of C and N are equal. Okay. So this is about the direction cosines and direction